Next, we're looking into a network hydropower project here in South Africa. This project started at the University of Pretoria. It was funded by the Water Research Commission, and Professor Van Vuren and his student, Marco Van Dijk, asked whether excess energy in distribution systems could be used to generate electricity. Most of South Africa's water supply is pumped up to storage facilities from where it gravitates into the network. There's an opportunity whenever there's low demand from the consumers, and you can use the high pressure to generate electricity.
This is a Pelton turbine, only a 1 kilowatt. The water would enter the turbine through this pipeline. It will be forced through a nozzle. The nozzle then increases the velocity that hits the buckets, and that would in turn turn the turbine. The water from this would then fall straight into the reservoir through the opening here at the bottom. A very small unit, but there is still application for that in the Conduit hydropower environment.
Once the concept was proven, it was time to expand, and Bloemwater came on board.
Based on the study done by the University of Pretoria, Bloemwater decided to pursue the implementation of a hydropower plant at our Brandkop Reservoir.
The Caledon Bloemfontein pipeline supplies potable water from the Welbedacht Dam. The treated water is pumped with a high-lift pump station 6.7 kilometres to the De Hoek Reservoir. From De Hoek, it flows through gravity mains 47 kilometres to 8 Cape Reservoir and a further 59 kilometres to Brandkop. 8 Cape and Brandkop can generate 350 to 400 kilowatts each, using a 96 kilowatt cross-flow turbine.
The turbine that we use here at Brandkop is a standalone turbine. That means that we are not tied to the grid, to the Eskom grid. And the electricity that we produce out of the synchronous generator that is connected to the turbine is in use for the Bloemwater office only. The process we follow is that the main line that comes from Welbedacht Dam is dissipating the water into the Brandkop Reservoir through 5 control valves. With it, there's a lot of pressure in the pipeline, which contains then the energy that is going to be dissipated in the reservoir as well. To make use of this energy, we decided to take a part of the pipeline. We rerouted that to the hydro turbine, and it goes through the turbine, and that drives then a generator. The synchronous generator produces then the electricity, which is going to be used by Bloemwater's head office only. The water that comes out of the turbine actually goes back into the reservoir via a channel underneath the turbine. And there's no contamination whatsoever into the water as such.
The cost associated with the turbine was about $55,000 US. The electrical work cost about $44,000 and mechanical work about $39,000. In total, the project cost was $194,000 US. The sharp-eyed among you will have noticed that this was back in 2014 to 15. The payback period was 7 years. For the last word on lessons learned, I spoke to Marco, the student on the project, who's now a lecturer at the University of Pretoria.
Obviously, a big advantage for Conduit hydropower installations is that there is no need for most cases environmental impact assessments. It is water that's already flowing through the pipeline. In many cases, a turbine can just be installed in an existing chamber at the end of that pipeline, stay involved in it. And although, yes, it's running and it works, there is constant sort of support needed by them from, let's say, the designers, in this case it was me and my team, that to keep it running, because they would like to make a modification or a change, and you would like to say, okay, but what will that impact? But that they now generate clean renewable energy from their own infrastructure is amazing. And I think there's really scope, and that's the other thing we saw from this, is that there's scope for further improvements and further expansion, and even linking it to other renewable sources like a solar PV on that same site. If you start building the infrastructure for one, you could maybe piggyback onto that and build additional infrastructure or utilize the other infrastructure like the roof of the reservoir. The city of Tshwane, for instance, have already gone and took a mayoral committee decision that any new reservoirs that they build, the designers should also look whether or not there's an opportunity to include some hydropower at that reservoir site. The city of Tshwane has gone and built some plants, some pico and some micro installations. And then Rand Water had, a year ago, they had a tender out for the installation of 4 sites, or the potential to install at 4 sites. And in total, that would have been between 12 and 13 megawatts of Conduit hydropower that could be generated. Hopefully, there are more water utilities and municipalities that will start incorporating this, and in this way reduce their carbon footprint.
Thank you, Marco. This is a beautiful example of how research to implementation succeeds when there's a truly collaborative relationship.